Word problems involving absolute value of inequalities. Recall that in solving for or finding an absolute value of number, let's say absolute value of 5, that is positive 5. Absolute value of negative 5, that is still positive 5. Why? In a number line, this positive 5 and this negative 5, notice that their distance to 0 is 1, 2, 3, 4, 5 for positive 5. For negative 5, it's 1, 2, 3, 4, 5 also. That is why their absolute value is positive 5, because absolute value is the distance of a number from 0 in a number line. So similarly, absolute value of negative 9 is positive 9 because its distance to 0 is 9. Let us take this given example. Suppose that you are allowed to drive within 8 kilometers per hour of the speed limit of 90 kilometers per hour without getting a ticket. Write an absolute value inequality that models this situation. Then, write an inequality that shows the speeds that you are allowed to go without getting a ticket. So, let S be our driving speed in kilometers. So, it is written in this expression, S minus 90, because 90 is the speed limit of that certain road. So, it is absolute value because it can be more than 90, and it can be also, the car can also run lower than 90 kilometers per hour. But there should be a limit, and that is 8 kilometers per hour. So, it should be less than or equal to 8 kilometers, or less than or equal to 8. And this is our absolute value inequality form. Now, to write our speed such that we are still allowed to go without getting a ticket, so we'll just simply remove this absolute value symbol, and we'll just simply write S minus 90 is less than or equal to 8. But we should also consider the other side, that is more than or equal to negative 8. So to simplify this, we'll just simply add 90 in each expression because we want to isolate S. So negative 90 plus 90, that is S. Then 8 plus 90, that's 98. 90 minus 8, that is 82. Therefore, our speed must be more than or equal to 82, but less than or equal to 98 kilometers per hour. So we can see this visually. By the way, it is written in inequality form, and this is how it is written in notation form. Now, if we want to see it visually in our number line, so we'll just plot the limit, so 82 to 98, and the speed limit of that certain road is 90. So ideally, this should be our speed. It should be less than this one to avoid accident. But there are cases for consideration. Sometimes when you're overtaking, you're accelerating to 94, 96, until 98. If you will go further than that, you will be given a ticket, a violation. You cannot also go lower than this because it might cause a traffic, or it may also lead to an accident if you are driving too slow with a speed limit of 90. In our given number 2, the length of a standard basketball court can vary from 84 feet to 94 feet inclusive. Write an absolute value inequality that describes the possible lengths of a standard basketball court. So, in here, let us visualize the given. So, in here, the borders are already given, 84 and 94. But the center is not here. So, visually, we can easily find a center. So, of course, that is the midway from 84 to 94. But how are you going to solve it? So, just simply find the difference of 94 and 84, and that is 10. Then divide it by 2, and that is 5. So, it means the distance of 84 to 89 is 5. The distance of 94 to 89 is also 5. Now, let L be the length of a standard basketball court. So, a basketball court can have a length of 84. It can have 86. It can have 90. It can also have 93 or 94, but it cannot be 95. It is not considered standard anymore. It cannot also be lower than 84, which is 83. So it's not considered as standard basketball. Now, how are we going to write the absolute value inequality form? So if L represents the length of a standard basketball court, this is how our expression or sentence looks like. Absolute value of L minus the middle, 89, is less than or equal to 5 because that is the distance to its limits, 84 and 94.